Right guys, so let's just go through this question. So it says the polymerization of ethene is a commercially important process. The free radical addition mechanism for polymerization of ethene is shown in table 2. The initiation step and 2 propagation steps are complete. The termination step is incomplete. The RR represents the compound that produces free radicals. Okay, right, in order to produce free radicals there needs to be an homolytic fission. That means that the bond breaks equally. So if we have a covalent bond, one bond represents a pair of electrons. Okay, 1 2. So if it breaks equally, it will form radicals. So we've got one radical and another radical. In an exam you might even come across it looking like this. Okay, that also means 2 radicals being made. Now for this first question, it says complete the termination in table 2. Okay, so A is completing the termination step in table 2. So to complete that, this is what we need to do. Okay, let me just go through the process quickly. So initially what happens is for the initiation there's a homolytic fission, so that produces the radical. So for free radical addition polymerization, what happens is we need to make monomers become polymers. Okay, so to begin with, the monomer will be an alkene. So in this example we have ethene because we've got 2 carbons, but it could technically be any alkene, but they usually ask about ethene. Okay, so what happens is this radical that we've made from homolytic fission will attack the double bond. Okay, so it will attack the double bond and it will attach itself to the ethene. Okay, so what will happen is, this is essentially what it looks like: CH2, CH2. Okay, so when the radical breaks the double bond and joins at the end of the CH2, it will make the overall molecule a radical. Okay, because this is a radical. Okay, we're not getting rid of that radical, we just added it onto the carbon chain. Now for propagation, it carries on happening. So this radical that we made, okay, this is just another way of writing it, is going to go and attack another ethene molecule. Okay, so when it attacks this ethene molecule, again it will break the double bond and then join itself onto this one. Okay, so we have, so what's going to happen is, this is what it looks like. So this was the radical that we had to begin with. Okay, and it had a dot. Okay, that's showing the radical. When it attacks this, let's just draw the ethene, CH2. CH2 is going to break its bond, so it will no longer have a double bond, it will just have a single bond, and then that bond that's being broken is going to be then made between this radical and this. Okay, so there is a bond made between this and the ethene. Okay, so again the overall molecule will then be a radical. So the radicals will keep on attacking ethenes over and over again until a termination happens. That's where 2 radicals meet each other, okay, and they bond with each other. So for the termination step, this is what you need to do. Okay, so for the termination, basically we get another molecule of this, okay, or it could be any radical from the steps above, but you know, just to make things simple, we just copy and paste this. So CH2, CH2, CH2. Be careful with the number of carbons, okay? We have 1 2 3 4, 1 2 3 4. Okay, so we're going to create a bond between these 2 radicals. So right, so what's happening is this one, let me just show you another way of showing the bond. Okay, CH2, 1 2 3 4. Okay, basically what's happening is these radicals are bonding, meeting head-on, and a bond will form between these two radicals. So we will have two R groups at the end, okay? So the product being made is, let me just cross this, just move this up, okay? So if we have one of these and another one of these and they bond together, we get, okay, we're going to have 8. Right, so just to confirm, the product being made, I just did it wrong the first time, so I'm just going to rewrite it. There wasn't enough space. So it'd be RCH2, CH2, CH2, CH2. Okay, now there will be 8 CH2s in total. Okay, so this is what the termination step would look like. Essentially what we've done is we've joined this molecule with this molecule, okay? So it's the same molecule, they're both radicals, okay? So 1, 2, 3, 4, 1, 2, 3, 4, okay? And this is what we get as the product. Okay, so this is no longer a radical.